Okay, we are officially doing the last section in the textbook. That's it. We're going to do the last section in the textbook, which continues this idea of probability. I haven't checked your homework yet for probability because I record this on the day that you're doing the homework on probability. So I don't know if there's any questions yet. I haven't had any throughout the day. It's now the evening and I haven't had any yet. So I'm assuming it's going well, but I hope so. I do want to talk a little bit though about lines of best fit and your graphs. Just a few little critiques so that when you do your test and when you do your assignments, you do them well. First off, when you do a graph, label your axes, what they are. So if this one is time, then label it time. If this one is distance, then label it distance. Okay, I need to know what they are. The other thing that I would say is choose a scale that is not too close together. Some of you are trying to put like 5, 6, 7, even 8 graphs on one page. Everything is smushed together and you're not getting accurate lines of best fit. You're not getting accurate pictures of what's going on. Because the lines are so smushed, sometimes you can't tell whether the dots are trending up or trending down, and so your line of best fit is actually going in the wrong direction. So you really need to make sure that you have them spaced apart. The other thing is if you do it and all your dots end up being like up here, then why do you have all these numbers in here? You didn't need them. Start your numbers where you need them, all right? And if you need to skip a bunch, do the little little wavy line down here to say I skipped a bunch of numbers and I'm gonna start counting at 100. All your dots should not be way up in one corner of your graph. They should be all over your graph. That would tell you chose a correct scale. Lines of best fit. Again, if you find that your dots are trending downward, I'm just making that up, but if you find that your line is trending downward, then your line of best fit should not be going that way. Your line of best fit should be going this way. Some of you had all of your graphs, so your line of best fit was going up. I'm not really sure how you managed that, since the trend of a couple of the graphs should have been that your dots were headed downward. So really be watching those things, okay? Your numbers have to go up as you go across. You can't start your time at 20 and go down to 0. You have to start at 0 and go up. Same thing with distance. You have to start at 0 and go up. I think that's pretty much it. Label your axes. No more than 2 graphs per page. And that doesn't mean put 2 graphs up in the corner and then leave the rest of the page blank. It means really those 2 graphs should take up a whole page, because otherwise you're smushing too much together and you're not getting an accurate picture. That is actually how statisticians trick people, is they do things like get the information to all bunch up in one spot to make it look like it's doing one thing that it's actually not. Or they make their scale really, really big to make it look like everything is really far apart. They manipulate things. The more you learn about statistics, the more you learn how you can manipulate it and how easy it is to manipulate things. And the more interested I am when I read studies that say, 56% of people said this or 95% of people said this. I want to know how that study was conducted, and I want to see how they did their math, because I can make anything say what I want it to say. If I do things like, one of the things they do, and I know because I've done it, is they gather all their data, and if there are some things that don't fit, so all the dots are headed here, but they find there's 3 or 4 dots out here, which would throw off all their information, they just go, we'll ignore them, right? Well, now all of a sudden you're dropping data that could actually be important. So the more you learn about statistics, the more you learn about how you can manipulate it, and how people like advertisers and marketers do manipulate it to make it say what they want it to say. So that's my little rant about statistics. All right, we're doing the last section of the book. So section 9.5 talks about independent events. So in probability, sometimes more than one thing happens, but one thing has absolutely nothing to do with the other one. One has no influence on the other. Those are called independent events. And so the example that they talk about is, they talk about rolling a die, and they talk about flipping a coin. Now, with probability, with something simple like rolling a die and flipping a coin, we can make something called a tree diagram to explain all the possible outcomes. I don't like doing tree diagrams because very quickly they become very, very large, and you don't want to do them anymore. But if we're talking about flipping a coin, if I flip a coin, right, we've all done that, flip a coin. I don't know whether I want chocolate ice cream or more chocolate ice cream, because really, it's always chocolate. But I don't know whether I want chocolate ice cream or whether I want death by chocolate ice cream. Like, how much chocolate do I want today? And so I'll flip a coin. And so heads, I want chocolate. Tails, I want death by chocolate. So there really are 2 possible outcomes when you flip a coin, heads or tails. Now, if I were to also roll a die, okay? So if I were to roll a die, there are 6 possible outcomes. I could get a 1, a 2, a 3, a 4, a 5, or a 6. So if I were to do both, roll a die and flip a coin. Well, if I flip the coin, here are my 2 possible outcomes. So here's what I mean by doing a tree diagram. If I were then to roll a die, if I were to get heads when I flip the coin, and then I were to roll the die, I might get heads and a 1, I might get heads and a 2, heads and a 3, heads and a 4, heads and a 5, or heads and a 6. Now, if I were to flip the coin and get tails and then roll the die, I could get tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. So, what are my possible outcomes? I could get heads and 1, I could get heads and 2, I could get heads and 3, I could get heads and 4, I could get heads and 5, I could get heads and 6, I could get tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, or tails and 6. So this is it written as a tree diagram. Okay? When I write out all the possible outcomes, all the things that could happen, this is called the sample space. The sample space are just all the possible outcomes that could happen written out. That is my sample space. Now, if I asked you, and if we were at school, I'd give one of you a coin and one of you a die, and we would try this. And if I said, what is the probability? So I'm gonna give Carson the coin, don't spend it, and I'm gonna give Schneider the die, all right? And if I were to say, Carson, I want you to flip the coin, and Schneider, I want you to roll the die, what is the probability that we will get heads and a 5? So that Carson will flip the coin and get heads, and Schneider will roll the die and get 5. Notice the words that I use in there. I said, what is the probability that we will get a heads and 5? So I use the word and. These are independent events, okay? They're independent because whether Carson gets heads or tails has absolutely nothing to do with whether Schneider rolls a 1, a 2, a 3, or 4, and a 5. One does not influence the other one, so they are independent events. When we have the word and we're asking, oh, what's the probability that this independent event will happen and this one will happen? When we see the word and, that actually means that you should multiply. Yesterday we talked about if you have the word or, you should add. If you have the word and, you should multiply. All right, so what is the probability that I get heads and that I roll a 5? Well, if you write out your sample space, or if you write out a tree diagram, you don't actually have to do any math, because remember, it is number of favorable outcomes over all possible outcomes. So there's only one favorable outcome, and that is that Carson rolls a head and Schneider gets a 5. That's the only favorable outcome. Okay, if that happens, we have a big pizza party. Okay, we don't, but let's pretend. But, so there's only one favorable outcome, but how many outcomes are there? There's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's actually 12 possible outcomes. So there really is only a 1 in 12 chance that Carson would roll heads and Schneider would get a 5. Now, mathematically, what if I didn't have a tree diagram written out? What if I didn't have a sample space written out? How would I figure that out? It's not hard. Here's how I would do that. I would go, what is the probability that Carson will get heads? Well, it's 1 out of 2, right? Because there's 2 possible outcomes, only 1 chance that he's going to get heads. And means multiply. What is the probability that Schneider will get a 5? Well, there's only 1 favorable outcome, him getting a 5, but there are 6 possible outcomes. Now, if I multiply those together, when you multiply fractions, multiply the top with the top, the bottom with the bottom, or hey, just use your calculator. 1 times 1 is 1, 2 times 6 is 12. See? Same answer. All right, I want to talk about types of questions that could be asked, because these questions people get wrong all the time how it's worded. Okay, I'm looking for something. Okay, so let's say I have that dish that I had here yesterday. I still haven't taken downstairs, but hey, I ate all the M&Ms. But let's say this had M&Ms in it, okay? And let's say there were 5 blue M&Ms, 6 red M&Ms, and 3 brown M&Ms, okay? So that means in total there are 14 M&Ms in this, okay? There's 5 blue, 6 red, and 3 brown. Now, if I said that I'm going to reach in and I'm going to pull out an M&M, I'm going to look at it, I'm going to go, oh look, that's cool, M&M, and I'm not going to eat it. That would be a lie, but I'm not going to eat it. I'm going to put it back in here, and then I'm going to do the same process. What is the probability that I get 1 blue, 1 red, and 1 brown? Okay, what is the probability that I get 1 red, 1 blue, 1 red, and 1 brown? even though there's no and in between this, it's implied. One blue and one red and one brown. That means I'm actually going to multiply. So what is the probability that if I reach in and I pull out one, that it's going to be blue? Well, again, there are 14 possible things that I could pick. 5 of them are blue. So let's say I do that. I pull it out, I look, I go, oh look, I got a blue one, right? I don't eat it. I put it back in, all right? So then I hand the container over to Emma. And I say, Emma, I want you to reach in. What is the probability that when you reach in and you pull out an M&M that you are going to get a red one? Well, there's still 14 M&Ms in the container because I didn't eat mine. I put it back in. So there's still 14 in the container, but there is a 6 out of 14 chance that Emma will pull out a red one. And then what is the probability if I hand this to Kiera? What is the probability that Kiera would pull out a brown one? Now again, Emma put her M&M back in, I put my M&M back in, so there are still 14 M&Ms in the container. There's only 3 brown ones though, so Kiera only has a 3 in 14 chance that hers is brown. So what is the probability that all 3 of those things happen? That I get a blue and Emma gets a red and then Kiera gets a brown. Because it's and, we multiply. And so again, we actually multiply across the top. 6 times 5 is 30 times 3 is actually 90. And 14 times 14 times 14 is 2,744. There is a 90 in 2,744 chance. Now, I would check with my calculator and see if that reduces. I just put the fraction in and hit equals. There is not. It doesn't reduce. But if I change it to a decimal, that is actually 0.03. And if I multiply it by 100, that's a 3% chance. There's only a 3% chance that if I put 14 M&Ms in here, 5 blue, 6 red, 3 brown, that what will happen is we will get a blue and then a red and then a brown. So it doesn't sound like it would be that big a deal, but there's actually only a 3% chance that that would actually happen. So here's a question that stumps everybody. Okay? If I ask you this question, what is the probability that, given the same scenario, we pull out an M&M, look at it, go, oh look, and then we put it back in. So there's always 14 M&Ms that I'm pulling from. What is the probability that we will get 4 brown M&Ms? At least half of you would tell me there's 0% chance that you will get 4 brown M&Ms because there's only 3 brown M&Ms in the container. But that would not be a correct answer. Here's why. I'm always putting the M&M back in. So the first time, what is the probability that I put my hand in, I pull out an M&M and I go, oh look, I got a brown one. Well, there is a 3 in 14 chance that I do that. So let's say I do that and I put it back in. I don't eat it. It hasn't gone anywhere. It's back in the container again. Now what are the odds that I reach in and I pull out another brown one? Well, there's still a 3 in 14 chance. Okay, so let's say I do that. I put it back in and I reach in again. What are the odds that I'm going to get a 3rd brown one? Well, again, 3 out of 14. And then what are the chances that I'm going to reach in again and pull out a brown M&M? Well, again, that's 3 out of 14. Each time I do it, I have a 3 in 14 chance. But what is the probability that I do it the first time and the second time and the 3rd time and the 4th time? That's where I multiply. So if I do 3 times 3 times 3 times 3, that's actually 81. And if I do 14 times 14 times 14 times 14, that's actually 38,416. So there's only an 81 in 38,416 chance. And again, if I see if that reduces, I'll just put that in my calculator as a fraction and hit equals. Nope. When it changes to a decimal, it's 0.002. If I multiply that by 100 and change it into a percent, that is actually 0.2%. There's a less than 1% chance that if there's 3 brown ones in 14 M&Ms, that the 4 times I reach in, I will get a brown one every time. So if someone was trying to make a bet with you, I wouldn't take it. All right. That's it. That's the end of your learning for this year. So I'm going to give you some homework to do on that. And then Friday, I will briefly do a review video, and I do mean briefly because we have not been very long in this. So probably at most a 10-minute review video. And then Monday is a holiday. So Tuesday, 8:30 in the morning, we will do a test on chapter 9. All right? And then we will be done Math 9, other than I'm going to send you the assignment. And again, I will make some review videos on the things that we covered when we were still in school. All right? Everything else, you can go back and rewatch any video that you want to rewatch. Kind of the bonus of this. There are some good benefits. All right, and that's it. We'll talk to you again soon.